Merry Christmas and Happy Holidays to all of you across the world, actually. Pretty amazing how much this has grown over the last few years. So what we're going to do is a little special thing in this video. What I'm going to do is give you a free, full-length sample from one of my videos on my paid channel. And on the paid channel, the difference with that is, of course, with it being $3.49 a month, less than the cup of coffee costs at Starbucks or whatever, you will get really in-depth, specific, step-by-step training in a lot of the things that you probably struggle with when you watch a lot of my videos, and that is the electrical, when I'm measuring things with the voltmeter. Sometimes I'm looking at amperage, sometimes I'm measuring voltage drops, sometimes I'm measuring resistance or continuity, and you don't really understand what those are. More in that channel, I focus especially on my basic electrical series. We take anybody off the street and they'll be able to go to any electrical system in a car and know exactly what they're looking for. And we do it very step by step and simply. We also look through a lot of the scan tool analysis and parameters. So when I'm looking at the scan tool and looking at various data on that channel, we break down very specifically what I'm looking for, what those parameters exactly are. So it's a little bit kind of step down from here for people that really want to get that foundation. A little more dry, a lot more of the dry erase board of knowledge type stuff, but also we got some really good case studies. Anyway, here's what we're going to be doing today. I'm going to give you a video from I think it's part 3 now of the Diagnosis and Understanding Electrical Systems. And after this video, I'm going to give you a Christmas story. Actually, my favorite story, I think, from the years of doing either of these channels. It's really kind of a cool story. And what we're going to do is give you this free video, but before that, I want to challenge you to identify which of the following groups you fall in, because a lot of you guys are kind of on the fence. Well, I don't know that I want to pay for the channel when I can get content for free. So I'm going to help you with that. It's my Christmas gift to you other than the video. One set of people is going to look at the video and they're going to say, oh, well, I already understand all of that and I know how to do all of that. I do it all the time. So there's no value in me paying $3.49 a month. And I would agree with you. And the channel's not for you. It's not for people that already have mastered that stuff. Another set of you is going to look at that and you're going to say, wow, I kind of understand it. Actually, I don't really understand it, but man, I would love to do that. I want to learn how to do that. I see that if I could do that kind of electrical magic stuff and diagnosis with the scan tool and not even open the hood half the time, I would love that. You are the target audience. That's the people that $3.49 a month would provide value for. So watch this video, and if you're not understanding it, but you're thinking, man, I would love to be able to do that, you should look at the channel. I will put the link in the description. A third subset of you guys is going to watch the video, not understand a damn thing I'm doing, and proudly proclaim you don't need to because you can just smell a spark plug and know exactly what's wrong with a car. I would agree that you wouldn't have any value in this channel, but we also, I think, both know how well that's really working out for you because I see you in line in front of me at AutoZone every weekend, so I know how that goes. But I do want to admit that there wouldn't be a value for you. However, you are watching a video that is titled Diagnosis and Understanding Ignition Systems. So are you really being true to yourself? A final subset of you are people that I would not expect to find on this channel either, and that would be, I suppose, people that do look at it, don't understand it, but totally see value in it, but they don't want to learn it. They don't want to put the effort in. It's hard to imagine there would be people like that on this channel, but I will admit, if that is your disposition, the channel is not for you. You still have to work at this. You still have to watch the videos very often several times over and even look at other sources. So I would agree, no value for you. Maybe you'll just enjoy this video though. There is, of course, one final subset, and that is people who want to learn the material and are interested, but they honestly can't afford the $3.49 a month because they're in a third world country. country, something that will have to do with my story, my Christmas story at the end of this. And I want to remind you guys that all you got to do is send me a PM, click on my name on any of the comments below or on the channel heading, and you go to the About tab and you can pull my email address. Send me an email. I will vet that you are from a developing country. Some people, I think, take offense to third world, I don't know, but a developing country. And once I vet that you are from there, I will give you free access to the paid channel. I have hundreds of people that are already doing that. We also upgraded the paid channel, something that I think some of my subscribers there are painfully aware of because we were down for a little bit and had a few complications, but we're up and running now. I expanded to get better bandwidth and everything to accommodate everybody better. So if you got a little frustrated with the channel because of that, check it out. I've upgraded the server, and we should have more bandwidth, and things will run a lot smoother with everything like billing and video play, whatever. So that said, let's go ahead and start this video, and then we will conclude with a little Christmas story at the end. So we're going to jump right into the middle of the series, and you can see which one of those 4 groups you fall into. All right, quantum mechanics, welcome back. What we are going to do in this video is a little bit like the last video. I'm trying to come up with different ways to approach the same thing because you guys all learn differently. Some of you guys will learn better from some of the stuff we did in the last video by just kind of hunting and pecking at the ignition system, gathering the data, and from that building the wiring diagram yourself. That's actually, as you know, in many of my videos, the way that I often do it. I actually do it a little differently. I do it more like we're going to do in this video, where I actually have a predisposition. And I'll look at the system, and based on my experience and having done this before, I will then put together the wiring diagram in my head and then validate it. We'll actually draw out the wiring diagram, though, just from looking at the system. That's kind of where you guys want to get to. And then in the future, the next video, what we'll do is we'll do it the way that probably most people would do. And that is they will get the wiring diagram first, read the wiring diagram, and then take it to the car. Any way that you do it, there is nothing wrong with it, whatever works best for you. I'm just going to show you the way that I generally do it. And what we're going to do is use one of our favorite cameo actors. This is, of course, my 2000 Trans Am WS6 that I affectionately call Blackbird. And Blackbird, as most of you guys know, had a major upgrade about a year ago or so with a brand new Corvette engine that's supercharged. Blackbird's running 710 horsepower at the rear wheels. How about that? It's going to be a little loud, so we're going to try to do a lot of this without the engine running. But the reason we're using Blackbird is because he has our most complex ignition system in the series thus far, and that is he's got the 4-wire coil-on plug system. Actually, it's not truly a coil-on plug. Pretty much if you understand a 4-wire system, you're also going to understand the 3-wire system. And of course, you're all experts on the 2-wire system now. So this will be kind of a natural progression up quite a bit. Also, as I mentioned in the last video, we're going to step things up now. I'm going to assume that you've mastered our basic electrical series. You will understand when I need to be on the ground, when I need to be on positive, what my connections would be with the test light. So we're going to assume you know all that. If you don't, you'll want to rewatch those videos. You're going to get lost. And we're going to kind of accelerate through this one a little more rapidly. So let's go ahead and get started. Okay, we're going to go over to bank 1 on here, and sorry about my stabilizer bar in the way here. Maybe I'll remove that if that gets in the way, but we're going to focus on this guy here, which is number 3. And what we're going to do is look at this system, and based on just looking at it, I'm then go to the dry erase board and do what I'm hoping you guys will be able to do after we finish this whole series, and that is just from looking at this, we're going to be able to draw out how this diagram must work. So one of the things, I think I mentioned before that this was a coil-on plug system. This is actually technically not. This is actually a coil near plug system. If we look here at the bottom of the view, let me move the camera, we can see that actually that is a spark plug wire here. But it's very, very short. It's a very short spark plug wire, and that's called a coil near plug system. So that's very similar to the coil on plug system. The only difference is that you've got approximately a 6 or 7 inch spark plug wire that is connecting each coil that is located directly above each spark plug. So for all practical purposes, coil on plug. The nice thing I like about the coil near plug is this allows me to use my scope to do that secondary ignition testing by clamping the spark plug wire, something that we found, of course, we couldn't do in the last video because of the coil on plug design. So as you know, we made up for that by just measuring the primary ignition, and we will get into some other things to do when you're in that situation now that you know difference with primary and secondary. If you're only able to access primary, that can be a little limiting, and we'll talk about that in future videos. So what I want to do is, we've got a main connector here for all of these. That's actually kind of cool. One of the things we wanted to do is talk about that modular ignition design. A lot of the waste spark systems we talked about have that. That modular design, that'll be when you have that coil module, you know what I'm talking about, where it's a box with the 4 or the 6 or maybe the 8 towers on it, each spreading out to each spark plug. And that is essentially what this is. It's just kind of exploded out. So that's actually pretty good for the video. One really big advantage with something like this is, in this case, it's not applicable because all our coils are readily available. But as you know, on many designs, you've got at least half of the coils, if not all of them, under the intake manifold. So, of course, your 98%er is going to have to pull the intake manifold off to replace things. And, you know, they're probably not even going to test it anyway. Hell, they might even buy all coils new because they don't want to replace them one at a time and keep replacing the intake manifold, right? People like us, however, are going to be able to access this connector, which will often be from outside of that intake manifold, and we'll be able to do our coil testing and ignition testing without removing the intake manifold. So that's another advantage when you understand these designs. All right, now looking at this design, each coil has a connector under it, and each connector has 4 wires. One of the problems here is that being able to back probe these like on that last video so that we can show some of the testing is going to be very difficult on this. So actually what we are going to do is we're actually going to step things up, and I am going to use this common connector for everything because I really don't feel like pulling the coil out, because even if I did, I just don't think there's enough clearance here that I can back probe it. So, and as you know, there's some dangers in if I ground out the wrong thing, that's going to be a major problem. So I want to be a little more cautious about that. So we're going to go through this main connector here. Okay, let me get this tape off the main connector. And what I want to do is I want to count the number of wires on this main connector. There is also going to be this same thing on the other bank as well. So let's move up. Let's check our wiring here. And let's see. We have 1, 2, 3, 4, 5, 6, 7. 7 wires at that main connector for bank 1. Just from that information alone, given the basic electrical series, given the previous videos in this series, there is enough information just from that I believe I can draw a wiring diagram of this system. How about that? How useful would that be? So let's go ahead and try to do it. Okay, what we are going to do is we're going to draw out this system. And it may not be correct, but I'm just showing the way that I normally do this. I can guarantee you it's going to be pretty close to what it actually is. And we're going to know that because I'm also going to pull a wiring diagram for this system, which is pretty easy. I've got several sources, including the actual factory service manual. And we're going to see how close my diagram is, just strictly based on my understanding of the videos that we've watched earlier. Okay, so we have 8 ignition coils. We'll go ahead and just draw them as circles right now. Now, the fact that they're not two-wire systems, we know it's not going to be like what we saw in the last video where the transistor has to be located in the PCM. We know the transistors are going to be located in each of these coils. That we know for sure. Okay, so each of these coils is going to have transistors. We know we're going to have power feed. There was a red wire on that main connector. Here's our main connector up here. That's not PCM. That's our main connector. There's also going to be another main connector here. It's that big white connector that we saw earlier. All right. We know there's going to be 12-volt power. This power wire is going to actually branch off like this and feed each of our coils. That is going to go to our primary coil, which will of course go to our transistor. Okay, and then of course inside here we've got our secondary coil. We covered all that, so we won't go into it again. Same thing's going to happen, all of these here. Same thing's going to happen on this side. Okay, so this is our 12-volt constant with key on, engine off, or key on, engine running. As long as the key is on, we're going to see 12 volts on this red wire, and it's going to every single one of these coils directly to the primary. Okay, we also had a green and a black wire, I remember. One of those, I'm just, again, from experience, I'm going to assume it's the black wire. Could be different. Either way, this diagram is going to be correct. The wire colors may not be. That's why I need to validate so that I can actually check the wire colors. The wire colors, I'm not interested in. I'm never interested in wire colors. I'm interested in wire function. Wire function is what you look at when you know what you're doing. Wire colors are what you do when you're still painting by numbers, which we're not doing here. We're understanding this. We're doing this by function. We know, based on the design on this system, this has to be a ground, okay? So I'm going to actually draw this ground down here. There's going to be a ground here, and a ground here. Now, again, from experience, we know because this is a 4-wire system, these grounds aren't going to the PCM like the previous design we looked at. There's no reason to do that. These grounds are also going to be common, and they are actually going to go directly to ground on the engine block. That's exactly how that's going to work. The same thing's going to happen here. These are also going to feed to a common ground that is going to go directly to the engine block. All right, now that of course leaves us with the control, and this would be your 3-wire design. So again, like I said, if you understand the 4-wire, by default you have to understand the 3-wire. So we're going to complete 3-wire design, which you guys already are familiar with. And that's going to be independent control of the base on the NPN transistor by the PCM. So let's put PCM over here. And of course, we're going to have control on the transistor base inside the ignition coil in this system. So we don't have ground side switching. It's actually, to be honest with you, it's positive side switching, pull-up switching, because this is going to feed a small positive feed into that transistor to activate it. So there is actually also going to be a transistor here as well, where the emitter is going to put that power out. So this is going to be how the PCM controls the firing of the individual coils. Remember, you've also got, we've talked about before, your inputs. How does it know when to fire those? Because of your crank and cam position sensor inputs that we talked about in the very, very first video. So we're going to have different wire colors for each of these. Again, each of these has their own transistor, and let's see, I don't think I have any other wire colors. We'll just do a red one also here. So you can see this is starting to complicate a little more, but that's going to be our independent control for the firing of each of these coils. And as we know, we get the spark when that electrical circuit is discontinued. So the opening of that switch so that we stop the current flow in order to get the spark to jump is actually going to be controlled directly in that coil by that transistor, not through the ground side switching. So when we stop the current flow, opening the switch, it's actually in that coil. That also, by the way, is going to create another complication on our scope waveforms if we try to look at that voltage spike to see that spike on voltage when we stop our current flow. There will be a complication with that. We'll talk about that later. But basically, if you try to read that on this system, you're not going to see that voltage spike, and it'll all make sense to you in a little bit. But it's because the switching is not occurring after where you're measuring that voltage spike. It's occurring before because it's actually in that transistor. We'll get you there. We'll get you there. Don't worry about it. Okay, I'm going to break for an emergency public service announcement because it did occur to me that we shouldn't wait till another video, because after this video you guys are going to be fully capable with complete confidence of going to your own car's ignition system, whether it's 2, 3, or 4 wire system, and you are going to be able to map it out. But those of you guys with oscilloscopes, or even if you want to do it with a DVOM, as you know, you can do this, you may be tempted to look for that spark voltage spike. Okay? And you're going to be tempted to look for that. And on your 3 and 4 wire system, you're not going to see it the way that I showed you, and it may cause you to have a lot of concern. It would certainly throw you for a loop if you were doing a diagnostic, but also when you're trying to map out your own system. And I want to explain that to you. So let's go over that, because this is pretty important you understand. Let's make this very, very basic and quick since you guys have your concepts down. Okay, let's do the 2-wire system, okay? And we're going to have our PCM here with our internal switching by the PCM. Of course, that's going to be transistor modulated. We know all this. And what we would do is we would take our scope, of course, and we've done this in the previous video. We look here and here on the positive and negative, right? And the scope is going to show you that pattern that we discussed, okay, with that big voltage spike there. And we understand that that's going to happen when the switch opens so that we stop the current flow, get the spark, counter electromotive force, all that. Now, that's, of course, what we expect in this system. What I didn't tell you, and what's really important, is that this voltage spike phenomenon is actually happening on this side of the coil. That is a critical thing to understand, because when we look at our 3 and 4 wire systems, hopefully it's going to become clear to you when I draw out the 3 and 4 wire system why that is a critical phenomenon. What I want to do is I want to first prove this to you by bringing back in my 2-wire model, and we're going to show you that the voltage spike phenomenon is actually only on this side of the circuit, not on this side. This side of the circuit is actually positive 12-volt feed no matter what at all times, running, key on, engine off. The spike that we're seeing is actually an inversion from the huge voltage spike here versus 12 volts here. That's actually what it is. This is not on the positive side of the system. And as a matter of fact, the way I'm going to prove this is we're going to show our usual thing, but then I'm going to connect the positive of the scope to the ground. Now, of course, that's still positive with switch open, you know, your basic electrical. This I'm going to put to a chassis ground, okay? And what we're going to do is we're going to see, now, of course, it'll be inverted now, but we're going to be able to pull up that same exact thing on this side of the circuit. Do this on this side of the circuit, what are we going to see? we're just going to see 12 volts is all we're going to see. Okay, very critical thing, because that's what you're going to see on your 3 and 4 wire systems, and there's explanation for that, and it's important. First, let me prove this concept. Okay guys, here we are, same setup as last video. We should have our same settings still, as a matter of fact. There's our voltage spike that we're familiar with. Okay, so we know all about this. Now, look at my settings here that I've got with my connections. What I'm going to do is I'm going to take my ground connection off. And of course, this freezes the scope, so I need to reset it. I'm going to put this over to battery ground. And we've got this trigger on still, so I need to turn this trigger off. Now we're inverted, remember, but there's our voltage line right there. Okay, let me go ahead and invert this. Or uninverted, I mean. We see our positive 12 volt line now. We do not see the voltage spike. Now, here's what I'm going to do. I'm going to go ahead and leave this at ground. I'm going to take my positive lead from my scope. I'm going to put it on the ground side. Now, of course, when the switch opens, of course, we're going to see that positive voltage because we don't have voltage drop when there's no current flow. And let me bring my trigger back in. Okay, and there it is. And we are on the ground side. So what does this show? Just what I said. This phenomenon that the voltage spike is only happening on the ground side of the coil, okay, after the coil. That's where our counter-electric force phenomenon that we discussed, and you guys fully understand, is taking effect. It's not on the positive side of the coil, it's on the ground side of the coil. This is my positive lead on the ground. Okay, you guys understand that, I know, all right? Why are we not going to see that on a 3 or 4 wire system? Let's go back to the dry erase board. And actually, while I cut to do that, why don't you guys think why you won't see it? You guys have your basic electrical, you understand how the transistor works in the coil. There's a clue for you there. You guys may be able to come up on your own why you won't be able to see it. So why don't you try to figure that out, maybe draw it out even, and then let's go to the dry erase board of knowledge and see if you're right. Okay, let's see if you were right, and hopefully you're able to figure this out on your own if you thought about it and drew it out and used your skills now. So we're going to do this on a 3 wire, same thing on a 4 wire, but just simpler to draw the 3 wire, obviously. And we're going to make this very simple. We've got our battery positive. We're going to the coil, okay? And then we've got our transistor control. Let's draw our coil here. This is our primary coil going to our transistor control here, okay? We know this part here is going to go where? To ground, okay? That's not going to be switched by the PCM like this one is, okay? This ground is a constant ground. We know that this is going to be the NPN design feed into the transistor. This is from the PCM to turn it off and on. And if we look at this, let's think about where we're measuring. When we connect our back probes, it's more like this. Okay, so we have a connector here. So let's think about when we're hooking up the scope. We're connecting our scope here and here. On here, it's the same thing. We're reading here on the positive, here on the negative. The phenomenon is happening here. So technically, the other way to do it is the way that we did, and that's to read positive here, okay? And then on your scope, read negative at a ground, and you will get that spike phenomenon, okay? Look at what is happening here. What's different? Can you see it? Okay? Let's have our scope. We're reading the positive here. We're reading the negative here. The problem is reading the negative here. That's the answer to the question. The problem is reading the negative here because the switch is here. Okay? So we're reading on the negative after the switching occurs. Okay, let's redraw this so it's clearer. We've got our scope here. We've got connection here and here. And let's look at the two ways of doing it on this one. So we can have our scope positive reading here, our scope negative reading here. Now the problem is that because the switching is here, what happens when this switch opens and we get the spark? Once we stop the current flow and we get the spark, that voltage spike is here, not here in the wire that's eventually leading to our ground. It is here. That is where that voltage spike phenomenon is occurring. We can't measure that because we would have to go inside the coil. So we're missing it. Same thing over here. If we were to move, like we did in the last example, our scope positive here, and then send this one just to a chassis ground, okay, we're going to have the same problem. The problem is your voltage spike that you're looking for is happening here. This leg of the transistor is open, so you're just reading an open against ground. When your transistor has the switch closed and you're building up your counter-electromotive force, the problem is, again, you're not reading a voltage spike at that time, okay? All you're going to read at that point, would you read 12 volts? No, you wouldn't read 12 volts because we've already had the voltage drop at the coil, right? Basic electrical. So you're not going to be able to read this on your 3 and 4 wire system. So I just wanted to point that out so that when you try to do this on your own and you don't see that, that's right. You would expect this. Now, that said, there's some ways that we can compensate for this so that we can test if our primary and secondary is working in those 3 and 4 wire systems. But that's for another video. But this is very, very important concept to make sure you don't get thrown for a loop. Okay, let's get back. As you can imagine, there's going to be on the one connector we looked at, I wish I had another color. You know what? I'm going to just do orange here. Hopefully this is a dry erase marker. I don't know if it is. We're going to do orange right there. Okay? Now, we know, because there were 7 wires, we know 4 of them are going to be independent controls. And we've drawn those out. 4 of those wires have to be the independent on-off controls for the transistors in the coils. We know that because we understand the system. That's 4 of them. 1 of them is going to be a common ground. 1 of them is going to be a common power. Sorry, it would help if I put my hands up to the camera to keep count. That's 6 wires, okay? That is, right there, our 3-wire system in a more modular design like what we've got here. That's your 3-wire design. We know that. The 4th wire is where it gets a little complicated. And what that 4th wire is going to be, and I'm going to draw the 4th wire in black here. That 4th wire, I'm going to draw it on this guy, is going to be... We saw this in that Toyota video, and I mistakenly thought that the 4th wire would be for a PNP transistor design. We know that would have not been correct because that would have replaced the NPN base input, and in that case, we still would have had the same number of wires. You would just have this being a grounded to create the activation on the transistor instead of an input to create that activation on the transistor. So it's definitely not for a PNP design. I still have yet to see that design in any car. What we know this is going to be, and we learned this in the last video with that Toyota, is this is going to be a validation that spark occurred, and we'll have to talk about this. On that Toyota, it was called a IGF, if I remember correctly. And what it is this goes to the PCM, okay, and what that IGF does is the PCM reads that. It determines that the coil fired. That's going to be the same thing on this design, except it's not going to be called IGF because that's a Toyota thing. On this design, it's going to be called a ref low. And we're going to talk about ref low in the future because I've always looked at ref low as just being a ground, and I've tried to Google it and research it for this series, and all you hear people say is, oh, it's just a ground, or it's a ground that goes to the PCM. And I think a couple things are different about it. First of all, I think it's a monitored ground. Think about it, it has to be. We already have a ground. We already have a ground for the coil. Why will we need another ground? You don't need it. The only reason would be if you're going to read something off of it, right? So there's got to be that. The other thing is I'm a little bit skeptical on how people say it works. They just say it's a ground through the PCM. I believe it makes more sense to me that there would be a resistor in here. And you guys from the basic electrical series are putting together. We know that because if we're going to measure, the PCM is going to measure with a DVOM, an internal DVOM, there's going to be no voltage on this line when the current goes through, right? There's no load. So by putting the resistor there, this would allow it to determine whether there was a voltage drop. All of that, of course, you guys understand from basic electrical. So I'm not sure on that. I don't know. It's possible that there is indeed a straight ground through the PCM, and maybe it measures current. Because it wouldn't be able to measure voltage here, you can see that. The voltage would always be zero whether or not the coil fired. So I'll have to do some more research on that, and if any of you guys know, put it in the comments and we can validate it. But it does make more sense to me that this wouldn't be a true ground. The other thing is there's no reason we couldn't do like the two-wire system and run the ground through the PCM. Of course, when you run the ground through the PCM, you would have to have, you know, those transistors would have to be pretty heavy duty, which is fine. But the thing is, you could also measure if it was not done through a resistor here on a two-wire system. Why couldn't we just run these right through the PCM? I'm thinking the reason you can't is because if you were to run a two-wire system, let's just do a real quick two-wire system. Okay, and then you got your on-off switching inside the PCM. Well, the trouble is if we were going to monitor this using the tactic that we talked about is commonly used with sensors, and we put a resistor here, well, the trouble is now with a resistor here, we wouldn't have zero voltage when the switch closes, right? We would have voltage here and then zero after. So that should easily make sense to you guys now. That's why I believe this reference low probably isn't a straight ground. And I actually have an idea on how I can test that and see how it works. I will admit, I don't know how it works. I'm learning this stuff along with you. That's kind of the value of this, is seeing also, not just so you can learn it, but how you would learn it. I don't know either. I actually do not know how the ref low works. All I know is it has to be a way for the PCM to measure that coil fired. Now, that diagram probably looks a little bit complicated. It would be even more complicated because, remember, we also have the same thing going on this bank with different wire colors, but it would be the same thing. One of the things also that you'll commonly see, and again, I just know this from experience, is this 12-volt positive you would think is the same, but I can tell you from experience what actually happens is each of these runs on their own independent fuse on each bank. And then here it's connected actually usually through the PCM with that ignition switch. So ultimately, it's still the same system that a lot of you kind of more old-timers are familiar, where it's directly with the key-on ignition switch. You still have to have the ignition on. It's just through the PCM, and it splits each bank with its own fuse. That's what I expect we're going to see. I may be wrong about that. That is our diagram. That is kind of messy looking. Let's see the actual diagram and see how correct we are. And then either way, I'm going to leave this up here because in real life, I wouldn't actually look at the real diagram. What I do is I check my work here and see how accurate I was. So let's look at a real diagram now and see how close we got. Okay, this is actual full wiring diagram of my Trans Am. And what I've got is 4 pages here, and what I did was I took the 4 separate pages and I did that trick I told you about where I connected the pages together and taped them to make one continuous wiring diagram. Makes things so much easier. Some markers here, and we are going to draw this out just enough to confirm that the wiring diagram from my head works. Again, normally I wouldn't do this. In the next video, we'll do it this way, where we'll start from the wiring diagram and then take it to the car. The only time that I do that is when I'm completely unfamiliar with a system. If I'm completely unfamiliar with a system, I'll get the diagram and draw it out, and then I'll understand it. What I want to do is I want to start again with the load. And I realize that you guys are not going to be able to read this. And to be honest with you, neither can I. But here are our ignition coils. There's 1, 3, 5, 7, and then this is going to be 2, 4, 6, and 8 over here. So there's our ignition modules. We can see, and what did I tell you? They don't show the transistors in the ignition module. All it is just a box, and it says ignition coil number 1. That's all. So our diagram is actually quite a bit more accurate. This one says ground. We're going to follow this black one here and check it out. There's a split right there, okay? And this split goes to the ground here. It goes to the ground here. And it goes off here. Oop, missed another split here for number 7. There's a ground there. And it goes off here. Right here is our ground. It actually says left cylinder head. Remember in my drawing over here? That ground right there, that is a fixed ground actually on the engine. Okay? So far we're looking pretty accurate. And this is going to, again, we know it's going to go to a split. There's a split point right there, and we know it's going to go to a ground on each of those coils, so we don't really have to draw that out. So we can just stay focused on this particular bank right here. Kind of zoom in a little bit for you there. Going to get a pink marker. We're going to find our power. Here's one that says IGN. Okay, IGN, that's going to be ignition. This is going to be our power. It comes up, and it's going to go to a split, I guarantee. There's a split. Right there is a split. One goes to that coil. One goes to that coil, to the IGN. It comes up. Wait, we were missing one. There's got to be another one. Here it is. Here it is. See, if you already know what you're looking for, you don't really need the diagram. I already know there's got to be something else there. That comes up. This says pink here, so this is our main connector. That's pink. Comes up, goes over. That is going to go to a fuse and eventually to the PCM. So let's follow it along. We're going to follow it along. Goes to the next page. Follow it along. It goes to the next page. Follow it along. Now it's finally branching up. Let's see where it goes. Branches up to a connector, okay? This connector, check it out, these are fuel injectors. So this also controls all the fuel injectors on that bank, on that one bank, goes up. This is a fuse right there, okay? And this is under a hood fuse block. There is also connection here to this fuse. That fuse is going to go to the other bank. Let me bring that down for you. That fuse is definitely going to go to the other bank. If we follow that one down, it goes to the injectors just like the other one does. It follows down. We'll follow that down to be sure. These are going to be both powered ultimately by the same source, and that is right here. This is a fuse that says ignition on, IGN on, right there where it's circled. So there's your ignition on, powers one bank. This is going to go power the other bank. We're going to follow this along. That's going across several pages. All the way to the last page. Finally comes down, look where it goes. Right back to where we were drawing earlier. Right there. So that's feeding our second bank here. So now we've got our power and our ground figured out. We already knew it though, actually. All right, let's go over to our first drawing here. Okay. Oh, and I just realized something. We forgot one thing on our diagram. Remember, each of these is going to have another wire coming off of it, a fifth wire. What's the fifth wire? That is going to be the spark plug wire. That's each going to go to our spark plugs, right? So almost forgot that. So technically it's 5 wires. The spark plug wire is still a wire. Just happened to see that on the diagram and remembered I forgot that. Okay, let's go back here. Okay, what I'm going to look for now is the individual ignition controls. We're just going to look at one of them now. So I'm going to do this in green. And this here says ignition control signal, IGN, CTR, SIG. So we're going to follow this up. This is going to be a single wire. This is not going to be shared. Moves up the page here. Let's back out. Comes across here. It is a single wire into the PCM. It says ignition control number 1 right here. So that is going to be that NPN transistor input to turn that transistor on and off to activate the coil or not. Each of these coils is going to have one of those going for the independent control. So I'm not going to draw each one just simply because it'll complicate the diagram a little more. Okay, now let's look at this one. Okay, and here we have in orange, sorry I accidentally used my green marker again, but this is all orange. This is our ref low. Okay, so the ref low, if we look, it comes up and eventually branches off, but it splits here. Okay, and we've got the ref low splitting this way onto that guy. The ref low splits this way onto this guy. So this is interesting. I kind of expected the ref lows would not be shared, that there would be individual ref lows so that the PCM could see that each coil fired. These are shared, so we'll talk about that because I do know how that works. It branches up off here and goes to the ref low here. 1, 2, 3, 4. That's our 4 ref lows. It's also, I don't know if this ref low is going to also share with this bank. I'm going to say these are probably split. So let's find out. Let's follow this ref low. And it's not going to split off. So each bank has its own ref low. There's a ref low right there. Let's look at where the ref lows go here. Okay, so here's a ref low right here. It splits. It's going to go off to all the other ones. We know that, so I don't have to draw it. and it's actually this wire right under the first one. So there's two ref lows side by side right there. So each bank has its own ref low. Again, that's going to be to determine the coil fired. It's a little more complicated in the fact that it's shared. So it must know which coil fired because of the cam and crankshaft input. And basically these are going to all be on that same ref low line repeating sequentially. And the computer has to determine which signal coming in is from which coil based on the cam or crank position. And it's a technique called parading that we can do on the scope, where we can see all of these, and then there's some other things we can do to identify which signal is which. So if we saw one of those signals on that parade that we didn't like, we would have some ways that we could identify which coil that was coming from. And we'll get there in the future. That's a little more advanced. Pretty easy to do on this car, though, because we can measure it by current through the common ground. Right? There's our common ground. So we could measure that parade with current wherever it was easiest. We could measure it at this common ground. We could measure it here. Okay? So that actually is more tools in our tool chest that, again, if we had an engine design where we can't access the coils, we have two potential sources where we could take measurements on the ignition and determine whether we need to take an intake manifold off or not. We actually have a couple sources there. Anyway, we covered all the wires except for, of course, one more. There is one more wire, and that is the spark plug. It actually says spark plug right there. So when we count up our wires from the connectors, we'll have 1, 2, 3 wires that are shared, and then of course 1, 2, 3, 4 individual wires. There's 7 wires for our connector. Okay, admittedly my diagram not quite as pretty and linear, but we do have the same things. We've got our 12-volt branched feed, we've got our branched shared ground, we have individual coil control to the transistors, and then we have the 4th wire on each of these. I wish I didn't draw it. I need more colored markers, I believe, for the more complexity that we're getting with our electrical videos now, don't I? But each one of these is also going to have the low ref. Now, this one caught me by surprise. This low ref is shared on each one per bank. Okay, there is another low ref here that is also shared. Okay, so there's our 7 wires. So I think I mentioned earlier I was kind of surprised that the ref low was not individual, and now thinking back, there's only 7 wires, so of course I would have put that together pretty easily, that it had to have been a shared ref low, because otherwise we would have had, what would it be, 10 wires, right? Okay, that looks disastrous. So here's what I'm going to do. I'm going to clean that up a little bit. We're just going to look at one coil and redraw this out, and then we're going to go to the car and we're going to validate that what we're seeing in the car is actually what we believe we have up here. So let me clean this off. Okay, we're going to just draw this out a lot cleaner, and we're going to draw it with only 2 coils now instead of 8 or even 4. We know each of these coils is going to have the transistor inside of it. It is not going to be ground side switched at the PCM. Let's put our PCM here. We know we have our ignition power feed. We know this is a shared feed that's going to go to the primary in each coil, to the collector. We know that we are going to have a shared ground at the emitters that is fixed, constant ground, not ground side switched, constant ground on the block. We know we're going to have an ignition control input into the base. Again, just our basic electrical here. All you guys know this. Actually, that would be 3 because these are on the same bank. It's going to be our low voltage input controlled by the PCM. Oh, and look, I do have an orange marker. We're going to have, and we'll look at this in more detail later. This is going to come off here. We'll have to determine this. Shared, going in, low ref. Okay? And what I want to do is I want to validate this on the car because, again, we know for a fact this is the way it looks because we looked at a wiring diagram. So we know now where we would focus in given different issues or whatever, where we suspect an issue may be based on symptoms. But again, in real life, I'm probably not going to do that. What I'm going to do is I'm going to draw this from what I believe it is, and then I'm going to validate that it's correct. I wouldn't look at a wiring diagram normally because a lot of times it's just too time consuming for me to look. And also, you guys have seen, because I'm limited in my sources, very often my wire diagram is inaccurate. That's happened about half the time. So that's another reason why this is my preferred way. What we're going to do is go over to the car. Now, normally what I'd like to do is I'd like to test each of these at the coil. As we saw at the beginning of the video, I was a little surprised that I can't do that. I'm going to have to test it at the connector. So what that means... So, once again, I don't want the wire colors. I get all the time people emailing me and commenting, you didn't show the wire color. What's the wire color? Who cares what the wire color is? It makes absolutely no difference. If you understand what you're doing, you go by function, not by color. Once I determine the function, if it's easier, then I'll fill in the colors here. So what I want to do right now is verify that this is correct. The way you verify it's correct is through function, not through color. Going through color is how you get in trouble because we've seen the wiring diagrams wrong. So let's go back to the car and see if we can figure out how we're going to go through that connector because I can't access the plug very easily for each coil. How are we going to go through connector and make sure this is correct? So let's go back to the car. Okay, lots of ways I can do this. As you know, generally my favorite way is the DVOM. I just like the quantitative output. There are going to be limitations actually on this. Really, especially for some of the input signals, the scope is really the best way because you want to see that square wave. The other thing is that because this is going to be very fast and rapid, my DVOM is going to jump all over the place on the input signals. A test light actually would be a better way to do it if you didn't have a scope, but really the scope would be the way. So what we're going to do is just do a couple of validations, and I'm going to get my DVOM up here. Okay, here's our setup here, and you guys know your basic electrical already. Also, we went over this step by step in the previous video, so we're going to go through this quicker as promised for you guys that are on the bus here. And what I want to do, the first thing I always like to do is the easiest one, and that is try to find the power. So what I'm going to do is turn key on, engine off. And let me turn off that blower motor. Okay, so for the power, and again, I could look off that wiring diagram and know exactly. That's typically not how I do it. I can tell you there is a red wire here that I like as being the power feed for everything. So I'm going to back probe that wire, and I was wrong. Okay, so it is not the red wire. So hard to imagine that red wire would be a ground. I'm going to say most likely that red wire is going to be the control to one of the coils. Of course, I don't know which one, and don't care right now. I'm trying to find the power, but it's not the red. I think that's a pink wire. Pink is also good. There it is. There's my positive feed. Okay, so pink wire is going to be my ignition positive that's going to feed all wires. Just to be sure, going to look on my wire diagram. There's ignition positive. Pink wire right there that goes off. It's a pink wire. So you can see I didn't need the wiring diagram for that. I was able to determine it through function. Saves me time. The black wire. So how am I going to determine that black wire, which I believe is ground, I'm not sure, what I'm going to do is I'm going to test continuity. Okay, so I'm going to put a noise signal on here. So we're doing continuity test. When I find ground, of course, we're going to be able to easily detect it. Now, just because I find a ground here, it doesn't guarantee that it is that shared ground for everything, but this black wire I kind of like. Okay, we see that we have it there. What I can do is look for grounds on other wires. How about that red wire? Nothing. There's a green wire over here. Nothing. One of the things, it's possible I could find a ground through one of the signal wires if the engine happens to be in the correct position and the cam and crank signal is calling for that coil to be grounded. So it is possible I could find it. I can tell you, given the thickness of this wire, I do believe the black is going to be the ground. Now, there's a way that I can verify that, and that is, there's my ground. That should stay constant ground running because, remember, we suspect it's grounded at the block. So if I was grounded through a switch circuit with the engine running, the ground would turn on and off. So I'm just going to start the car real quick and verify that we maintain our ground. Okay, you can see we're maintaining our ground. A little bit of noise on it with the engine running, but that is our constant ground, no doubt. Just double check our work on that. That is enough for me, but we're learning here. We look on our wiring diagram. We can see I just drew the ground in black. Of course, I almost always draw the grounds in black or green. And if we look at our grounds, we see that it is, here's our ground constant at the block, and we can see that it is a black wire. It does say black on there. So we have successfully, through function, identified our wire colors. That means looking at my wiring diagram, which remember is in my mind while I'm working on a car, that's going to be pink, not red. And actually, because my red marker's kind of faded, it does already look pink. So we've got those correct. Okay, now it's going to start getting a little trickier here. You guys can't see it, but what I'm looking for is, again, I'm using my basic electrical knowledge and the stuff from the previous videos. I know that given the 7-wire system, we're going to have different colored wires for each individual control. I know that. So I'm trying to look at the plugs here, but they're actually taped up really well because I did a really good job on this. And I don't like water getting into my electrical. But I can tell you there is I can't see what I'm really looking for, but I can tell you this. There's a brown wire on 2 of these. 2 coils both have a plain brown wire. Okay, right there, I know that brown wire is going to be that ref low. The other coils are going to have it too. I can't see it from here without taking it apart. But just that, just the fact that I see 2 coils that are sharing another wire, that's going to be the ref low. So that means any other colored wire is going to be an input to the base for that particular coil. trying to find the brown wire. There's the brown wire right there. So this wire right here is going to be my shared ref low for everything. I'm very certain of that. I could rule it out by looking at all the other wires and verifying there's independent control. I'm going to do that on just any one of these. Here is that red wire that I found earlier. Remember him? I thought he was the power feed. That is going to be an individual coil control wire is what that's going to be. So what I'm going to do is get a test light. All right, we know how these work. These are positive feed, so we'll set up accordingly. I'm going to put that test light in there. We're going to see that test light flash. Let's see, that's plastic, so I'm safe there. We're going to see that test light flash, indicating the control from the PCM. And that was not the constant power feed. So we don't need this anymore. Let's go ahead and do that. And of course, you guys know exactly how to set this up. All right. You can see it. There we go. Okay, so that confirms. Again, it's okay to make mistakes. I guessed that the red wire was constant positive. Obviously, it is feed. Now, we don't know which coil that feeds. And admittedly, that would be where a wiring diagram would come in handy. Matter of fact, since we have one, just because I'm curious, there's red, number 7. These are numbered 1, 3, 5, 7, the very back coil. Not saying wiring diagrams aren't helpful. Oh my God, truly helpful. I would have had other ways of finding out that that was the control for it, and we'll talk about that in future video. The final thing is the ref low. And you know what? That ref low, I'm going to see if you guys follow along on this one. Let's go to the dry erase board and let me explain to you what I'm going to do. Actually, better yet, let's save that for another video and talk about the ref low. The main thing, though, before we do that, before we talk about the ref low, is it's going to be a constant ground. That is going to be a constant ground because that is just going to be monitored. It's not a control circuit. So let's find that brown wire. Again, just proving concept of function here. That is the brown wire. That is going to be grounded. Let me reconfigure here, and you're going to see that this is definitely going to be grounded. Make sure this test light's in my shot this time. There it is, grounded, okay, all times. So my question is, how does the PCM read that ref low? And I have an idea, and we're going to save that for another video so we can go over it. All right, well, that's pretty much the way that I usually do it, and you've seen it in the videos, but now you've seen it more step by step. And given the previous videos on basic electrical and ignition systems, you can follow along and you can do that yourself on any car. You can look at a 2-wire ignition, a 3-wire ignition, or a 4-wire ignition, and you can do exactly what I did without a wiring diagram. Find the wires of interest. The only thing we haven't covered yet now is identifying common faults and things. And what we're going to do is we've got to do 2 things coming up. We've got to look at another 3 or 4 wire ignition system. And what we're going to do is we're going to start from the wire diagram, bring it to that car. We also didn't use the scope here to do some verifications. We'll do it on that car just so that we're not as duplicative. So we'll use the scope more on the other car. You can see you don't really even need the scope. DVOM and a test light, you can map out an ignition system, make your own wiring diagram. But we'll do more of that. And the reason being because then we're going to start getting into what is most important, and that is diagnosing issues. Right now we're just understanding the systems, how they work. Going to any ignition system and you know how that system works. Given that alone, you can do a lot of troubleshooting just with that. But we're going to look for some specific troubleshooting techniques, and in order to do that, we're going to have a little more understanding on the scope and some of the waveforms we would expect, because quite honestly, your test light and your DVOM are not going to be that reliable on ignition system testing. But we will cover it, as we always do, for those that don't have scopes. Right now, I owe you guys the Christmas story. Okay, I feel kind of like Burl Ives, except I'm alive. This Christmas story goes back when I first started the pay channel on YouTube. And of course, as you can imagine, there was some backlash about that. I received 2 emails, well, a comment and an email that I looked at pretty much back to back in the same day. And the first one was a comment from a guy, and he said, "I can't believe you're, going to charge for this, and why would I pay for this?" Pretty typical comment I was getting at the time. I told the guy, well, it's less than the cost of a cup of coffee, and I guarantee you I'm going to make you able to do all the stuff in this video that the guy indicated he didn't understand it anyway, so what's the point? And he would be able to understand it, and he can quit at any time. It's not a big deal. $3.49 a month. The guy responded with an objection saying, well, he just bought a new iPhone 6, I think it was at the time. I, at the time, was still using an iPhone 4, by the way, so I didn't give a lot of sympathy for him. And the payment with the iPhone and the monthly fees for service and cable TV and everything, and it's just another thing that's adding up, and whatever. Okay, so, it's his decision. I guess we know which group he falls into, because he can afford it. The second email was one from a guy whose name I couldn't pronounce, from a country in Africa I never even heard of before. I don't even know what it was. And by the way, if you're watching this, let me know who you are, because a lot of people owe you a favor, buddy. This guy from some place in Africa said that he's in this small village in Africa, and he explained that in this area where he lives, his family of 4, or maybe it's 3 or 4, lives off of the U.S. equivalent of $700 a month, okay? And he said that where he lives, there is no automotive technician training. He is a professional mechanic. It is how he supports his family. It is how he makes a living. But they don't have ASE certifications. They don't have automotive technical colleges. They don't have trade schools. You learn just by doing. And the guy said that he depends on my channel for his training. That is how he gets his training for his career. He said that because English is not his first language, and because I speak, as he said, articulately, and I use proper English and proper grammar, he finds that my channel is just the easiest one to follow because he can understand the English. And he says, this is how I get my training. He was very upset at the fact that I created the pay channel, not because it was $3.49 a month, which is a chunk of change for him, but because YouTube didn't make his country able to access pay channels. He said he contacted YouTube, he contacted financial institutions, he did everything he could to try to pay to get the content on the paid channel, was unable to do it. He asked me if there was any way that we could work something out off the side so he could get access to it. He was not asking for it for free. He was asking how can he pay for it. It really impressed me so much, and especially in combination with that first asshat, that is when I actually decided to make pay channel content free for all people in developing nations, and I've continued to do that since. So if you are in one of those developing nations, or I've done this for veterans who I just believe their story. It's kind of on the honor system a little bit, so I'm going to trust you guys. But I've done it for other people where I believe that they really can benefit from it, and that they would actually have a hard time even with the $3 a month or whatever. So I just want to remind you guys, PM me, go to my name in the over the comments, any comments that I respond to, just click on my name, you go to the About tab, In that About tab, somewhere in there, you can find my email address. And I just don't like to give it out because I get a lot of spam email. Do give me a couple weeks to respond. Keep in mind I get hundreds of emails a day, honestly, and I get 200 a day with my real job. So I really try to filter down to only those that are regarding the free channel, and I get a lot of spam, as you can imagine. So give me some time to respond. But I am true to my word. I will vet that you're from the developing nation or that you're otherwise in a situation where you would qualify for the paid channel content, and we will get it to you for free. So appreciate your guys' support on both channels. Love all of you guys. Thank you for watching, and have happy holidays. And do know that I'm going to be taking some very rare time off during the holidays, something I have not done in many years. I'm actually taking off a full week, and I plan on making content during that week for both channels. So hopefully you guys will see me a lot more over this holiday break. Thanks very much, and we'll see you again soon.